Hello, I am Edlabadkar from PVGCOET. We are here to learn the centrifugal pump and different heads. At the outset, let us understand different components of the centrifugal pump. This is the free water surface, this is the suction pipe, this is the delivery pipe, this is the impeller, and this is the casing which covers impeller. Impeller generates the delivery head as well as the suction head as well as the delivery head. Suction head is developed so as to enable the fluid move from sump level to the eye of the impeller, and delivery head to overcome the resistances along the delivery pipe. Different heads of the pump. So we have got the static head as well as this is the static head, which is nothing but the sum total of the suction head and delivery head. As you see, the vertical distance between the eye of the impeller and the sump level, free water level in the sump level, we call this as the vertical distance as the static suction head, and from this eye level to the topmost position to which the fluid is being pumped, we call this as the delivery head. So sum total of HS and HD will give you the total head. Total head, you do have some velocity head to be left with the fluid so that it will leave the delivery pipe. You will have some frictional losses in the suction pipe. You will have some velocity head to be left with the fluid in the suction pipe. So you will have some frictional losses in the delivery pipe as well as some kinetic head, as we have seen already, we talked it already, to be left with the fluid leaving the delivery pipe. Thus the total head is, if it is H, it will be sum total of static suction head, static delivery head, friction loss in suction head, friction loss in delivery, friction loss in suction pipe, friction loss in delivery pipe, plus some kinetic head left with the fluid leaving the delivery pipe. Generally, it is not possible to measure exactly the losses in the pump casing, so the term manometric head is conceived. Manometric head, if one has to say, it is the, if we have got one pressure gauge put up onto the suction side and one pressure gauge, that is suction gauge on suction side and pressure gauge on delivery side, and if we measure those pressures, obviously suction pressure will be below the atmospheric pressure line, delivery pressure will be above atmospheric pressure line. Sum total of these two pressures will be your manometric head. Hydraulic losses are the losses that occur between the suction and delivery end of the pipe. Manometric efficiency is thus defined as the hydraulic efficiency of any ideal pump. Thus, hydraulic efficiency of any pump is generally varies from 60% to 90%. The pressure at the outlet of the impeller is always higher than the inlet pressure. Thus, there is always tendency on the part of water to slip back or leak back through the clearances back to the suction side. These losses are to be accounted by the term known as volumetric efficiency. Mechanical efficiency accounts for the losses for the pump in case of because of friction in bearings as well as this friction as the impeller rotates in the fluid. Now, thus the overall efficiency would be the ratio of the total head developed by the pump to the total power input to the shaft. The overall efficiency generally varies from 71% to 86%. This is a typical problem which talks about a centrifugal pump that delivers 50 liters of water per second to a height of 15 meters through a 20 meter long pipe. Diameter of pipe is given as 14 centimeter. Overall efficiency being 72% and coefficient of friction 0.015, and we have to determine power needed to drive the pump. So we have given HS suction head as 15 meters, discharge being given 0.05 meter cube per second, length is 20 meter, friction coefficient of friction is 0.015, diameter of pipe being 0.14 meters, overall efficiency being 72%. And what we do have is the formulae for overall efficiency, which is equal to rho g QH divided by P. Rho is density of the fluid, Q is discharge of the fluid, G is acceleration due to gravity, H is total head being developed, which is sum total of suction head, frictional losses plus kinetic head imparted to the fluid in the delivery pipe. We can calculate the velocity in the delivery pipe by this formula, equal to pi by 4 d square Vd. Pi by 4 d square is the cross section area multiplied by Vd will be your discharge in meter cube per second. And if you see it, if you put up the correct values, you directly get the velocity of the fluid in the delivery pipe being 3.25 meter per second. And then you have got HF being calculated as 4.61 meter. Subsequently, we calculate total head being 20.15 meter. And the power to drive pump now can be calculated using this formula. And what we get, power output power required or power to be given to the pump will be 13.726 kilowatt.